quick tidbit about myself, and then we'll discuss what Sqoop 2 is. If you guys don't know what Sqoop 2 is, I'll give you a little bit of an intro. And then we'll discuss some of the changes that have happened in Sqoop 2, which are some good things, I think. So, I work on the ingest team at Cloudera. I used to work on Hue at Cloudera, if you guys are familiar with that project. And then before Hue, I did like ad servers, attribution, et cetera, et cetera. A lot of fun stuff. The clicker is not working. One moment, please.
I just pointed.
Do you have to point to the screen? I know.
Like,
Oh, whoa. All right, that works. Kind of funky. Okay, so yeah, that's a team photo with shirts and stuff. I want to brag for a second. Shirts were my idea. All right.
Fashion design.
Yeah, there we go. All right, so Sqoop 2, just to give you guys a little bit of an overview. Sqoop 2 is very similar to Sqoop 1. It's targeting kind of very similar goals, but we've got a couple of auxiliary goals that we have in mind. Ease of use, better security, and ease of extensibility. So you might ask why those three things. Ease of use is really big in my mind because who wants to use a tool that's hard? Ease of extensibility is also very big because I feel like a generic data transfer tool, yeah, it might get like 99% of those use cases out there, but what about the 1% that we don't cover? We want to be able to give people the ability to connect to data sources that we may not actually be able to connect to out of the box. We want to give people the ability to use engines or parallelize in a way that we may not be able to parallelize or something of that nature, right? It's a big thing. The other thing I think that is really big that I guess Sqoop 1 has some difficulty with, is security. The police officer or security guy up there. So security is massive from my standpoint, at least the way I see things. There are a few different ways you can connect to data sources, right? But who can actually access those data sources? And how do you define how you can access those data sources, as well as who are the people that are giving you the ability to access those data sources? So from my perspective, that's really big. And just out of curiosity, does anyone else in this room agree?
Yeah.
Sweet. So Sqoop 2, I think we're trying to solve security pretty heavily from my perspective. And it seems like other folks' perspective as well. So in the future, I'm hoping to see some like ACLs or role-based access control, things of that nature. Not really sure yet, but it's in our minds. Okay. I think it's my computer or something. Okay, so let's start off from like a really high level. What does it look like when I want to run something in Sqoop 2? Well, you have to submit a request. So Sqoop 2, unlike Sqoop 1, is a service. What that means is that we have a Sqoop 2 server and we have a Sqoop 2 client. And then the Sqoop 2 client is very lightweight. All it does is communicate with the Sqoop 2 server. And then the Sqoop 2 server handles things like metadata queries and spins off a MapReduce job or something of that nature. And so right now, all we have is MapReduce to parallelize the execution of your job. But in the future, there may be other things. Who knows? So what does that look like? Okay, it's just slow. So Sqoop 2 kind of has a well-defined workflow, if you will. There is an initialization phase, there's a partitioner of some kind, there's something that extracts data and something that loads data, and then there's something that kind of finishes everything up. So when you look at that, just out of curiosity, can you guys kind of imagine how this might map to MapReduce? I'm seeing a lot of yeses, a lot of nods, which is I'm happy with. So the partitioner is basically the thing that handles kind of your input splits. And the extractor is something that runs in the map phase, and we're reading data out of your data source. And then the loader is something that actually takes the data that we've extracted, and that's actually in the output format. and loads it loads it into Hadoop. And then the destroyer is something that finalizes the job. So that might be like, I don't know, rename a staging table or something like that so that you have consistency, or perhaps rename a folder in HDFS.
You know what, with APIs, you'll make like it something less scary than data destroyer. No one's going to run that.
Yeah, that's a good point. Terminator. So,
A little out of scope, but I have a question. I think you're the guy to answer it.
okay.
Okay. Hadoop, write a file.
Yep.
Hadoop DFS LS, 0 bytes. Hadoop
Okay.
DFS cat, I actually see data in it. Sometimes sequence file reader gets mad, says I can't read 0-byte files. Have you ever ran into this and know anything about the semantics of files that seem like they're 0 bytes but have data?
Right.
The sequence file format gets mad because it says they're 0 bytes when they're not.
Right. So personally, I've never ran into it,
Yeah.
but it does seem like there's something wrong with the metadata which is associated with your file. You might want to like do like a fs check system or whatever that command was from the command line. Such things may exist in CM. I'm not sure.
It's not corrupt. It's just that like the sequence file reader expects a header.
Yep.
Sometimes the sequence file is 0 bytes and the header doesn't write right away, but it's there,
Yeah.
and that blows things up sometimes. So I was wondering if you ever ran into that in the Sqoop world.
No, not personally. Anyone else in this room? Okay. No.
But can you, no, but can you give us an idea of where each of these things run? Like,
Yeah.
where does the partitioner run? Does it run on every node, or what?
Sure. So I've drawn out. Actually, let me finish with you. Let's talk offline about that.
Yeah.
Okay. Sounds good. So I've drawn out multiples to kind of define things that are parallelized, and single instances to kind of define things that are not parallelized. So the initializer is not parallelized. It's actually ran on a single node. It's actually ran, I believe, in the Sqoop server. The partitioner, also ran on the Sqoop server, is not parallelized. And so the partitioner is actually creating, in the case of MapReduce, our input splits. And then the first thing that's parallelized is the extraction phase.
So would that be on the edge node then? Or where would that run? Where would that partitioning be done?
So the partitioner sorry?
Well, I said, where's the Sqoop server?
Okay. So the Sqoop server is deployed to anywhere you want to deploy it. If you want it to be on the edge, awesome. If you don't want it to be on the edge, well then you're going to have clients that are not on the edge as well. Maybe the right client for you is Hue. I don't know. And there is a Sqoop 2 Hue client, if you will, or a visual kind of thing for Sqoop 2. So the extractor actually takes, first the partitioner is ran on the Sqoop server. What it does is it will usually do some kind of metadata query, and then we'll get an idea. For instance, for a relational database, we'll query like kind of a range that is available. If we have a where clause, we'll get the number of records available, et cetera, and then we partition that up.
So is that a potential bottleneck because all the data is going through one single node?
It's a metadata query.
Oh, it's a node, okay.
Yeah, so we're really getting metadata only. In fact, if you look at the query, we usually do something like 0 equals 1, and it never does, and all we do is get metadata.
Got it.
Yeah. So then we use the metadata to form input splits, and those input splits feed to mappers, and then the extraction phase is where we actually extract the data. And in I think it might even be the next slide, I'll describe kind of what the data looks like as it moves through the system. So the extractors are ran in the mappers. The loaders are ran in the output format, and I believe the destroyer is, I think, the output committer. Yep. That was much faster. Okay, so it's not this slide, but the next slide, I think, will describe kind of where the data, how the data moves in and out of the system. So, or how it looks while it moves in the system. So there's currently 2 different kinds of jobs that we can run in Sqoop 2. There are input jobs and export jobs. So what this means is that we're importing into the Hadoop ecosystem. Basically, we're connecting to some relational database or something like that, and then we're pulling data out of it and loading it into, like HDFS. And that is of Sqoop 1.99.3. Okay? And then the other is the reverse is true with exports. Must be a little further down. So if we keep the image in our mind of the initializers, extractors, etc. There's kind of a division of responsibilities currently in Sqoop 1.99.3. And so if we look at these tables here, we see that in the for import jobs, initialization, partitioning, and extracting, as well as destroying the job, is kind of owned by the connector. And in the case of exporting, initialization, loading, and destroying is owned by the connector. So in the case of importing, the Sqoop framework owns the process of loading. And for exporting, it's the extraction and partitioning. Do you guys see some overlap? Maybe a little bit, like there's a partitioner, extractor, and loader for framework, and then there's a partitioner, extractor, and loader for the connectors. So there's a bit of overlap, right? Okay. So this really brings to question, what is a connector then? What are the connector definitions? What does a connector do? So connectors define how to connect, extract, and load data to a particular data source. And so here are a couple of methods that you usually define if you're developing your own connector. And so,
Is this equivalent to the connection manager in Sqoop 1?
Sqoop 1. It seems similar, I don't know. Anyone else have any thoughts on that? There are various kinds of managers which you can use and load, for instance, Netezza manager, or for instance, the Oracle manager, or Oracle manager, or something like that, right? Those are what I would call equivalent to these connectors. I know that they do a bit more of those, so they're not exactly equivalent. In Sqoop 2, we've kind of defined the connector SDK. We've said, okay, these are the responsibilities of the connector, this is the responsibility of the framework, etc. So we've kind of limited the responsibilities of the connector to basically, how do I connect to the data source, how do I extract data, and how do I load data. Okay. So, okay, this is that thing that I said I talked about.
Does it also do any translation of the data types that aren't equivalent?
So Sqoop 2 has basically a number of data types which it supports, and then what we do is we translate data types that we don't support into data types that are known to Sqoop 2. So there's an intermediate data format, if you will. That's that one. An intermediate data typing, if you will. So there are Sqoop data types. Okay. So the intermediate data format. This is essentially what the data looks like as it moves through the Sqoop system. So right now, the only thing that's supported is CSV. And so if you can imagine, you have 3 columns in your relational, in your table in your relational database. Then basically there will be call 1, call 2, call 3. Pretty simple, pretty straightforward, right? Okay, cool. So what's wrong with this implementation? What are some of the limitations that we have? So I've described one thing that's wrong. We have kind of an overlap of responsibilities. We say that the framework extracts data, loads data into the Hadoop ecosystem and out of the Hadoop ecosystem. Also, I don't really think that this is a massive limitation, but Hadoop is treated as like a first-class citizen, which means that there's no from one Hadoop component to another Hadoop component kind of data transfers. I don't think that there are a lot of use cases for that, but it's something to keep in mind. The Hadoop ecosystem is not well defined. So one example of this is, Accumulo wasn't considered part of the Hadoop ecosystem, but then people decided, hey, I want to use Sqoop to transfer from a relational database to Accumulo. Okay, well, does that mean we should be able to transfer from Accumulo to HBase as well? So that's kind of not so well defined. And so with that, we decided to refactor things. What we decided was the connector SDK kind of did everything that the framework was doing. And so why not just kind of pull all of that out into the connector SDK? It's kind of what we did. We also created this concept of directions, which is basically source and target, if you will, but we called it from and to. Seemed more intuitive for some reason. There was a vote on it. It was pretty interesting. And we've decided to improve schema integration. This gentleman over here asked about data types and how they were kind of handled. What we did was we said, okay, well, there's going to be some typing, and we should have like a schema which defines what the data looks like as it moves through the system. And so we've improved upon that a little bit.
So this whole schema thing is all metadata related, right? So
Sure.
is there any synergy between that or Sqoop 2 and Navigator? I mean,
Navigator,
are you
okay.
guys thinking about that, or?
Yeah, I could see Navigator doing tons of stuff with this, right? So like maybe the schema is metadata that ends up in like a log file somewhere or something, and it's some kind of lineage, right? So with Navigator, you would be able to say, okay, where is my data currently, and where is it going to end up, and what does it look like? And so the schemas may be useful there. So it's in our minds. I can't say more than that, though.
Okay.
Yeah. So we've added from and to direction, and then we've decided that the initializers and destroyers, which are so negatively named, should be ran for both the from and to direction, if that makes sense. So you'll have two connectors, connector A and connector B, and you'll transfer data from whatever connector A is pointing to whatever connector B is pointing to.
Why not partition on the two side? Vertical can load in parallel, right? Every MPP database can do it.
Sure. Oh, interesting. So there's definitely, you want to kind of partition your data such that you parallelize the process of moving data, but it's interesting to kind of partition on the two side. That's something we didn't really consider, to be honest.
You showed in that diagram you had multiple loaders. You had 3 loaders and 4 partitioners,
Yeah.
which I took to imply that you wanted to have parallelism different on either end, because that's one of the things at the moment. Your parallelism on Hadoop and on the database has to be exactly the same.
Not necessarily. You could have, let's say you have 100 part files and you've got a Teradata database that you want to load it into. You could potentially set, 2 part files to go into, a certain partition, something like that. Configure that.
You could definitely see how like a columnar storage system might benefit from that, but I'm not entirely certain. It seems like a lot of use cases will be better the other direction, but it's something to consider. We should keep that one in mind. It's a good idea.
It's a huge use case if you're offloading the warehouse, but you're ultimately putting the data back into the warehouse.
Yeah.
You can definitely parallelize that.
Well, if you're loading back into the warehouse from Hadoop, then actually, yeah, that's interesting. Because you would want to partition basically. I don't know. It's an interesting thought.
The only thing you have to be careful about is a lot of these databases tend to lock their table
Right.
if you're doing parallel loads.
Right.
But then if you've got, an insertion load mode, which is not a bulk load,
Yeah.
you can potentially, like for example, Teradata has a concept of TPUM, and TPUM actually does not lock the table.
Got
And
it.
you can have multiple TPUMs, and there's still benefits of having those part files being pumped in. I mean, just a thought.
No, yeah, it's definitely food for thought as well, like something interesting.
Well, but you're doing the loading of the output committer, so unless there's one reducer or one mapper, then it must be parallelized, right? Because those things are happening in different places.
There's definitely parallelization, but the task of partitioning, which is I think what's in question, why not do it with the 2 connector? It's an interesting idea because if you're going to like a system that's columnar or something like that, then there could be optimizations for that system, which may be better than the optimizations for the front connector, which is something we didn't really think about, which is a very interesting idea, great food for thought. Cool. Oh, right. So, yeah, these are the responsibilities, shared responsibilities for initialization and destruction. Very negative. Partitioning and extraction will be handled by the from connector, which we've just discussed, and loading will be handled by the to connector, which we've just discussed.
Is it not working again?
There. Hope I didn't double click. So we've created an HDFS connector in Sqoop 2 branch, and yeah, so basically the HDFS connector brought us some pretty interesting problems. It's schemaless, which is kind of difficult to manage. Also, it's kind of an entirely new connector. So you have to handle data formats and things of that nature. But the schema listing was a real pain, and I'll describe how we kind of handle that in the next few slides.
You know what it might be? Let me shut this. Can you aim it right here? Oh.
Okay. 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 Yeah, I think if
We're just going to switch ports. Maybe it's the port.
All right, thank you. So some of the schema improvements that we had were there's going to be a schema per connector. And as we discussed, having a schema per connector is kind of an interesting idea. That means that if we're extracting from a data source and then loading it to another, that means we have to do something to make sure that those schemas line up. And so what we've done is we've created this concept of a matcher, which I'll describe in the next slide. Also, the intermediate data format now has a schema. What this means is that we can describe what the schema of the data as it moves through the we can describe the schema of the data as it moves through the ecosystem with a Sqoop schema. So there will be one record per kind of IDF, right? And then that record will describe, will have a description, which is our schema, and it's associated with the intermediate data format. Wait, that worked. Okay. So the matcher's job is to match schema A to schema B, and vice versa. So with HDFS, since it's schemaless, we have to use the schema from the from connector. That's just a given. There's no schema that we have with HDFS. It's kind of a limitation, I guess. But there are cases where we'll have both, and there are cases where we'll only have a schema with the to connector. And by the way, cases where there are no schemas, we've just said, you know what, let's not handle it for now. It's very difficult. So we kind of just throw an error if that happens.
So what's the format of the schemas again?
The schemas are basically lists of columns. Those columns have data types associated with them. And basically what you can do is you can say, if you remember intermediate data format is just a CSV, each column in that CSV will have a column description associated with it, which has like a data type, potentially a name, things of that nature. And it's based on index, so the first column will be associated with the first index of, first column index in the schema.
And this is probably a conflict of interest, but are you guys doing anything around the H catalog at all?
In Sqoop 2?
Yeah.
I think eventually, yeah. I mean, eventually we have to, right? Or like Hive or something at least, right? With the Metastore and all that, yeah.
Okay.
I mean, I don't see why not. But obviously,
are you seeing a lot of adoption of Hive Metastore, H catalog, metadata in your customers?
H catalog, I don't know. I haven't really been following it. Hive Metastore stuff. Oh yeah, come on. There's tons of adoption. Yeah. So we've defined kind of 3 different matching strategies which we perceive that will exist in the future. The first matching strategy is location, and that actually currently exists as our current implementation. Switching ports, I'm assuming. The second matching strategy is by name. So basically, if you have 2 relational databases that you want to transfer data between, like MySQL to PostgreSQL or something of that nature, then you would basically have 2 distinct schemas that you'll have to match, and you could potentially do it by column name. Okay. And the third one is user-defined. This one I think is really big, but it's not implemented yet. It would be really cool if you could define how you map a schema from connector A to the schema of connector B, pending the existence of such a schema. And with that, I have finished my talk. This is ingest.tips if you guys are interested in like ingest kind of things. Then feel free to check it out. All we really intend to do is improve the process of ingestion by making, things that people have done previously, making blog posts about it, and even if you guys want to actually contribute to it, feel free. It would be cool. So,
So